All right, practice problem number 2, associated with sample problem E. A scared kangaroo cleared a fence. That is useless. Q for that. A scared kangaroo cleared a fence by jumping with a speed of 8.42 meters per second at an angle of 55.2 degrees with respect to the ground. If the jump lasted 1.40 seconds, how high was the fence? What was the kangaroo's horizontal displacement? So let's take stock of the things that we know here. We know that we have an initial velocity. We know that we have an angle to work with. We know that we have a time. And we're talking about the y component, so we will be using later down the line. I'll show hopefully this will make sense, but we will be using an acceleration, but it's going to be acceleration in the y direction. Acceleration in the y direction is going to be completely due to gravity, but it's going down, so we have to represent that with a negative sign. So negative 9.81 meters per second squared. Now this makes sense if we define our coordinate system, plus plus, minus minus. So let's draw our situation here. We have ground, right, respect to horizontal. Here's the fence. Okay, hopefully that looks like a y component. That looks like a y-axis, and this looks like an x-axis, because that's kind of what the question sets up here. And let's see. Okay, so scared kangaroo clears the fence. Here's the fence. Okay, the y-axis. It jumped at an angle. Jumped at an angle with respect to the ground. See, respect to ground. Right from the ground. 55.2 degrees, and that velocity. Right, that initial velocity, 8.42 meters per second. Okay, and then obviously the second half of the parabola occurs. So we're being asked for how high was the fence, right? So delta y max, and we're being asked for the total delta x. But let's see, it asks us for the height of the fence first, so let's do the height first. Now, in order to continue to move on here, we have to remember that with this parabolic motion, that maximum height is reached in a time interval of half the change in time. Half. Okay, it's going to be very, very important, because if we use the entirety of this time, right, because the total change in time is 1.40 seconds, that's the amount of time that it takes for the kangaroo to go from its starting position to its final position. And if you just look at movement in the y direction, the kangaroo will have 0 y or vertical displacement, right? Because you're just looking at the y component, you're seeing the kangaroo go up and then come back down, and it actually ends in the exact same position. And, so if you use the entire time, but we know that kind of the peak of that parabolic motion is going to happen at half that time. So when we go to use our kinematic equation, we have to make sure that we're using half that time. So let's do that right now. So the value for delta t that I'm going to end up using is going to be delta t 1/2. Hopefully that makes sense. It's the time of half. It's half the time. Let's see. Well, it's going to be 1.40 seconds divided by 2, right? Divided by 2, total time, divided by 2, right? Divided by 2. And that ends up being, geez, I want to use 3 sig figs. So that ends up being 0.700 seconds. So I'm going to use that value for time when I'm going to be using this half value for time, half time, for my kinematic equation here for y max. Now, again, this is a triangle here, and so I'm looking for specifically the y max. Okay, not the total, not the entire result, but just the y component. And so again, here's the angle. This is opposite over hypotenuse. Okay, opposite over hypotenuse. So I have to use the sine of the angle. I'm going to drop that right in there. That's going to allow me to just use the y component of this velocity here. So I guess I'll write it. Y max is equal to that initial velocity, okay, that resultant, multiplied by the sine of the angle it's given, multiplied by the half time. Again, half time, not the full time. So this is the equation I'm going to plug some stuff into, and I believe I have everything, right? I mean, I have all of this stuff. I have my v sub I have the angle, I have my half time, I have the acceleration. Yeah, so I should be good to go. So this actually ends up being, see, what are my values? 8.42 meters per second. That's a sine of 55.2 degrees. Ooh, I'm going to run out of some space here. My half time plus, I'm going to have to start writing small here just to fit it. Whew. Oh, goodness. That looks fantastic, doesn't it? I'm so glad I went this way instead of just turning it right here. All right, so one of the things I like to do is kind of like break these parts down into smaller bits, just to make my calculator work a little bit. I don't know if easier is the right word, but it seems less stressful for me. I like seeing kind of the in-between parts of the calculation. And what's my units? There's a seconds and a second, so this ends up being meters. And again, that ends up making this value over here a negative 2.4. Again, it ends up being meters, right? Because this is squared, so those go away. I'm only left with meters. So simple arithmetic lets me know that ends up being 2.44 meters. So that fence is 2.44 meters tall. Okay, but we have a second part of the equation. What was the kangaroo's horizontal displacement, right? The horizontal displacement. So we are going to be using the same kinematic equation, but we're going to be going in the x direction here. Now, again, we know that the kinematic equation looks like that, but once the kangaroo has jumped, there's no change in velocity, at all. Because remember, we're not dealing with wind air resistance here. So acceleration will have a numeric value of 0, and because there's a 0 in there, that means this entire second part of the equation goes away. And so I'm just left with this part. But again, remember, I'm looking for the y component here, the y component specifically, not y component, x component. Gosh darn it. And so what I have to do is take into consideration that there is an angle, and so the question is, do I use cosine or sine? Well, here's my delta x, here's my angle. This is adjacent over the hypotenuse, so it's going to be cosine. So I'm actually going to drop a cosine of the angle right in there. So the equation that I'm actually going to solve for this second part of the equation, whatever. I'll put it in parentheses. Put in parentheses for no reason. My hand just moved. I don't know why. You don't need parentheses, but I made them anyway. So I have all of these values here, so I'm actually good to start plugging in numbers. So I can actually do my calculation. I can use my calculator. 8.42 meters per second multiplied by the cosine of, what's my angle? 55.2 degrees. And then I'm going to use the full time here, not half time, because I'm looking for the entirety of the x displacement. So I'm not going to use this 0.700 seconds. I'm going to use the 1.40 seconds that the question actually tells me is the entire jump. And in the calculator, I should be using, what, 3 significant figures. So given what my calculator is telling me, 3, yeah. So this scared kangaroo jumped over a fence that is 2.44 meters tall, which is a pretty darn tall fence to jump over. And given the velocity that the kangaroo was traveling at, the kangaroo actually jumped a distance of 6.73 meters.